So chapter 18, free energy and thermodynamics. It's fine. Nature's heat tax. You can't win. So energy transactions are like gambling. If you go to a casino and you gamble, eventually you will lose all your money because it's set up that way, right? Now, if you stop strategically, you could come away ahead, but if you keep going, you will lose. So energy transactions are like that. Ultimately, you're going to lose. The first law of thermodynamics says that energy is conserved in chemical processes, which means that energy is not really lost, but it's maybe lost to useful purposes. So burning gasoline to run a car. So about 20% of the energy from the combustion of the gasoline goes towards moving the car. The other 80% is largely dissipated as heat. And if you've ever had your engine overheat, and you know how hot that engine can get. So where did the energy go? It went into heat. So we've got the kinetic motion of the car, and we have heat. So the energy from the chemical reaction is equal to the sum of those two types of energy moving the car plus heat. But the heat was not very useful. And so the first law of thermodynamics, it's also sometimes stated as there is no free lunch. You can't win. You can't create energy that wasn't there to begin with. There's no way to create energy. You can only transform it from one kind to another. So you can't win, and you can't even break even. So the second law of thermodynamics we will state officially in a few slides. Let's look at an example of a rechargeable battery. So you can recharge the battery and use it, and it does 100 kilojoules of work, and then you go to recharge it again. It's going to require more than 100 kilojoules of energy to recharge the battery. And so some energy is lost. Not really lost because it's still there somewhere. The energy is not destroyed, but it's lost to the surroundings in order for the process to occur at all. And it's often lost as heat. And so we can say that nature imposes a heat tax. So every energy using or producing, some of you have more experience with taxes than others. And they're smiling. Nature imposes a heat tax. So every time we have a transaction, nature takes a cut of it. Okay, it's a bit like the government. You know, you buy or you sell something, and they're going to take sales tax. You earn money, they're going to take income tax. They just take a piece of everything, right? Nature does that. Any real-world process is less than 100% efficient. It's not possible to have a 100% efficient process. What is true is the fewer transactions occur, the fewer times you're transforming energy from one form to another, the more efficient the use of that energy is, because you're going to lose some every time you do something. So you can't even break even. You can't win and you can't break even. So let's look at heating your home with natural gas versus heating with electricity. If you have a gas heater, you burn natural gas, that generates heat that's used to heat your home. Does all of the heat go to heating your home? No. I don't know about you, but my gas heater is in the garage, right? So hopefully a lot of that heat's going through the ducts into the house, but some of it gets dissipated into the garage where it's not useful. So there's a heat tax there. If you have electricity to heat your home, well, where does the electricity come from? Well, oftentimes it'll come from burning fossil fuels to generate the steam. So we're using this combustion reaction to generate steam. There's a heat tax. We take the steam and we use that to generate electricity. There's a heat tax. We take the electricity and we need to transmit it from the power plant to your home, heat tax. And then the electricity going into the electric heater, there's also a heat tax there. So heating your home with electricity, many more steps, so you've lost more to the heat tax. So natural gas is more efficient for heating your home. Any questions? We, of course, try to reduce the amount of heat tax on each of these, but it's not possible to get rid of it completely.